of one of my favorite topics. Oh, there we go. Pythagorean Theorem. So, we'll go over two basic problems with Pythagorean Theorem, and then we're going to go over one using Pythagorean Theorem in like 3D. So don't forget your stat box. So in a right-angled triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the other two sides. So just writing that all out in words. Remember, these are your notes, so you don't have to write word for word what's on there, but what you need. We've got our right triangle here, and we've got c squared equals a squared and b squared. So the hypotenuse is equal to the sum of the squares of those legs. Remember that the hypotenuse is always the longest side. So it's always C. Oh wait, what? Sorry. Alright, so if we know two sides of a right triangle, we can solve to find the length of the third side. Been there, done that. We're going to do two different problems kind of covering both of those situations. And then just something to keep in mind, the converse of the Pythagorean Theorem. If we know all three sides of a triangle, we can plug those numbers in and determine if it's an acute triangle, an obtuse triangle, or a right triangle. Definitely things that I know you guys do in geometry, but I know it's been a while. And the next slide kind of just sums up the last point in like another way. So if a triangle has sides of length A, B, and C units, and a squared plus b squared equals c squared, then the triangle is right angled. So it's just saying if you plug those numbers in and it equals, then it is a right triangle. So same kind of stuff that we were just talking about. Let's just try this. So I want you guys to go for it. Remember, c squared equals a squared plus b squared. Go ahead and see what you come up with on this one. anyone share with us the answer that you guys got? Just want to see how you wrote your answer. Did you finish it, Ty?
Yeah,
What'd you get?
I really don't want to be wrong. I'd be staggered if I was wrong.
Oh, that's exactly right. What did you get?
1.28 meters.
And you even remembered the meters, which most people don't. I'm guilty of forgetting that too, but you get bonus points for that. Alright, so I'm going to go through it in case we didn't get there, but we do have the right, perfect answer right now. So we end up with, we know that our legs are A and B, our hypotenuse is C, so x squared equals 0.8 squared plus 1 squared. Does it matter the order these two numbers are in? Does not, so we end up with x squared equals 1.64. X is going to be that square root of 1.64, and we get 1.28 meters. All right. One thing that I want to make really clear right here is 3 significant figures. Have you guys heard of sig figs before? I really need to have nods, yes or no. Have you heard of sig figs before? All right, so if it is not otherwise specified, give your answers in this class in 3 significant figures, okay? The first few tests and stuff, I'm going to be easy on it, but eventually I'll start taking off points for that. And that's the kind of thing that when you get to the IB test, you can lose 1 point, 1 silly point for writing 1.3. All right, so we'll work into it. I'm not going to start screaming about it right now, but your answers should be in 3 significant figures. The exception is you might have a question that says, give me the answer to the nearest inch, or the nearest meter, or the nearest degree. If the question asks for that, then you'll have to give the answer that way. If it doesn't specify, you want 3 significant figures. All right, we good? So we're going to do one other type of problem before we move into 3D. Once again, find that unknown length. Just a friendly reminder that when you guys take your test that's coming up, you can't use cell phones. So you need to figure out a different calculator situation. Just a reminder. All right, anyone got anything for this one? Want to try it out? What do you got, Austin?
X equals 4.7.
All right, x equals 4.7. I'm going to add that 0 on there. And maybe you said it and I didn't hear you. But there we go. So once again, labeling this always helps. Got my legs, and then I've got my hypotenuse. So 5 squared equals 1.7 squared plus x squared. Now, does it matter the order of these numbers? Hopefully we get a yes on this one, right? Because the hypotenuse has to go in the C spot. Doesn't matter the order of the x and the 1.7 though. That can change around. So we'll get this up here. Oops. All right, there's one thing I have a looking at the example and I thought there was one thing I wanted to tell you and I forgot. I remembered it now. So we know when we square root, we get a positive and a negative answer. How come we only write the positive one down in this case? Exactly right. Thank you. You can't have a negative distance or a negative length. It's something you have to remember, though, because in the future, if you forget that negative answer, that's not going to go well. So keep in mind, in this case, since we're talking about lengths and distances, we don't have that negative there. Okay, any questions? All right. Oops. So now we're going to venture into 3D. I'm going to zoom this in so you guys can read it, and then we'll get to that picture. All right, so the floor of a room is 6 meters by 8 meters, and the ceiling height is 3 meters. Find the distance from a corner point on the floor to the opposite corner point on the ceiling. So we're thinking, if we even think about this room, if it's like 4 meters by 6 meters, that's the floor, 4 by 6. The height is 3 meters. What we are looking for, our final answer, will be the distance from the corner point on one ceiling to the corner point on the floor all the way over there in the corner. Okay? So then when we take a look, they have a really nice diagram here, and you're going to have diagrams on your assignments as well. But it outlines everything. So here's the 4 by 6 for our floor, the 3 for the floor to ceiling height. And if we take a look at this triangle right here, we've got the diagonal that's going down like the middle of the floor. So I've got 6 and 4. So X is actually the diagonal that's going from the floor corner to the floor corner. And we can sketch this out in a way that makes sense and looks more like a right triangle if we want to. And I do recommend sketching that out to help you make sure you've got everything in the right place. But now what we can do, and once we have that X, we can use that to help us find that diagonal length from the ceiling to the floor. So I know I breezed through that. We've worked on a couple of those. I'm going to recommend that we leave this answer as a radical for now. I think you'll see why when we finish up this problem, but just leave it for right now. So we know the floor to ceiling height is 3, and then we know that down the floor is square root of 52, so we can make another right triangle. Just like that. So I've got this right triangle going on here, which I can then use to find y. I forgot to mention this, but how did we know that these were right angles? Like, how did we know that was a right angle on the floor? What shape are most rooms, basically? A rectangle, okay. So in case we forgot about that, that's how we get that right angle. Also, the floor and the ceiling, we're going to assume we're making a perpendicular angle as well. So that's how we got that right angle here. And now we're going to get a much more accurate number because we did not round this. We left it exact as the square root of 52. So when I square it, that's out of there. So we've got y squared equals 9 plus 52. So we've got the square root of 61. And at this point, we do want to get an approximate answer for that. We're 7.81 meters. Again, I know that I'm going through the Pythagorean Theorem piece a little bit quickly because we kind of practiced some of those. But does it make sense with like the 3D and how we made those other triangles? Okay, there are a couple of those that show up, so hopefully let me know if you need any other help with those ones. So I've got, does anyone have Any tips for Pythagorean Theorem in all of your years of experience with it? Since like 7th grade, right? Probably a long time. All right, so do we have any tips? Okay. So I'm going to pass out this worksheet, but then I do want to just take a quick second to talk about the calendar. Then I'll come around and check in H, and we'll just go over any questions that you guys might have.